Okay.
Yes.
So in the last session, we are talking about how you can model a particular type of beam based on its support condition. Cantilever beam, simply supported beam, continuous beam. There are so many different types of beams based on the support condition. So the first example was about modeling of cantilever beam. So the same exercise we are doing where our objective is to validate the software result with your manual calculation. So these we have modeled in the last session, and we also have seen how to see the shear force diagram, how to see the bending moment diagram, then whether the results are right or wrong, that also we have seen. Then axis consideration for special beams, local axis system, like suppose if you want to see the movement, so axis, major axis for the movement is your 3 3, minor axis for the movement is 2 2, major axis for shear is 2 2, minor axis for shear is 3 3. So in simple, you have to remember that every time for the case of beam, every time for the case of beam, if you want to see the result for the beam as a shear force, so you know that the shear will develop along the, just a minute. Okay, so for the case of shear force, you need to go to display, go to force stress diagram, go to frame pier and spindles, and in this way, if you want to the shear force, so shear will develop along the depth of the beam. That's why we need to look at the axis 2 2, say apply. So shear along 2 2, shear along 2 2, major axis for shear. No doubt, shear will also be along the 3 3, but that will not be significant in your design. It is not having any significant, it is not performing any significant role in your design, or in making your beam unstable. So shear along 3 3 is not going to be matter. Only the problem with shear failure will be the axial forces, sorry, the shear forces that you are getting along the axis 2 2. And why we are looking axis 2 2, that I have explained in the last session.
Yes,
Yes,
sir.
sir.
Okay, so now finally, so go to display, go to force stress diagram, go to frame pier spindles. For the moment, the major axis will be 3 3, minor axis will be 2 2. So in the last session, we have seen that how you can model this kind of beam, how you can assign the load, and what kind of problem you need to face if you want to assign the load over the beam. Okay, so if suppose the point load, so we have seen in the last session, there is no any option except we have to model this beam in a section or in parts. Okay, that I have discussed in the last session. Like suppose if you want to have if you want to assign the load at this point, if you want to assign the load at this point, so what we need to have the joint here. But if I'm going to take the beam as continuous from this point to this end, okay, so if I'm trying to get the joint at this point, I'm not able to get the joint. That's why what option we have followed, we are taking this beam like this. Then I am going to take one other beam in continuity like this, then another beam in continuity, and then coming to end. So actually the beam is single, but we have modeled it in 3 parts, so that you will get the joint at this point. Got it? But that is not needed to do. Actually, in advanced way, you can directly model this beam as a single line. Okay. So, but there will be the same problem, like how you will get the joint to assign the point load. So how to resolve that problem, I will let you know. So go to file, go to new model, say no, open a new model file, metric SI, say simply okay. How many grid lines is needed? Tell me fast. If I want to model it as a single element from one end to another end. Hello?
2.
2. This is the first grid I need to have, second grid I need to have. Okay, so go back to your ETABS and just simply put 2, and in y direction as usual it will be 1. Spacing, so total spacing will be this is 0.5, 0.7 will be point 1.2.8, it is going to become 2 meter. So just go back and put here it as in x direction as 2 meter, in y direction at least you have to put 1. Okay, then now go to custom. Just there's no need to go to custom, let it to be as it is. Number of stories, I would like to have 2 and put it as 1 meter 1 meter. Okay, then go to edit grid data only, sorry, grids only, say simply okay. So you will have these 2 levels. Just close this 3D view and you will have these 2 levels. Sorry, this is the plan view. This is the plan view. So go to elevation. I would like to see the elevation view along the grid first. Say simply apply. So now you are at the you are actually in elevation view. So basically our intention is to create one level, but yeah, there I have put two levels. That's why I'm having 2 levels. So it's your choice. At any level you can work. But if you want to work at base, so at base it will automatically assign the support. Unnecessarily your execution, your steps will increase. Means you need to remove the support and then all. So what I'm going to do, I'm going to work over the story first. I'm going to work over the story first. Okay. So in one turn, I would like to model the beam from first end to another end. This is the first point. Take your cursor and don't click over that unless and until you are not getting the grid sign like this. Then click over that, freely move to the another point and then click over that, then right click. So you will have this kind of frame. Hello.
Yes, sir.
Yes, sir.
Okay. Now I have to assign the fixed support at the left end, drag it from left to right, select the join, then go to assign, then go to join, then go to restrain, and I would like to assign the fixed support. Check this fixed one, say apply. So here it is the fixed support and another end is hinge. Now the problem is what? I have to assign the point load at a distance of 0.5 meter from the left end. Now it is what? Point load. So to assign the point load, we need to select the joint as usual we are doing. So here I am trying to get the like joint at this point. I am dragging here, so I am not able to get the joint because there is no at all the joint is present. How you will get? Yeah, it is the beam end or beam frame end. So the frame end joint you will get because it is a frame end joint. But here if I am trying, no. Here I am trying, no. Then how I can assign the point load? So yeah, we can assign the point load to this. In this case, previously we are assigning the point load for the joint. Hello. Previously we are assigning the point load for the joint. Now we are going to practice assigning the point load to the frame. Hello.
Yes, sir.
Select the frame, then go to assign, then go to see joint load. So there is no any joint. Where we have to assign? Either on joint or a frame. Tell me.
Frame.
Frame. So go to frame. In frame, now it is asking whether you want to apply the point load or distributed load uniformly. Both of the thing. Suppose if any beam is there, so this beam may be subjected to uniformly distributed load. In addition to that, it may be subjected to point load. So both of the things are there. It is not always be like this. Beam will always be subjected to uniformly distributed load, line load. It is not like that. Okay, and it is not like that point load will always be at the joint. It is not like that. Okay, beam will be subjected to uniformly distributed load and there may be a point load. Okay, there may be a point load. So select the frame, clear this all. First select the frame, then go to assign. At this time I don't want to assign the joint load. I want to assign the frame load. Means I have to assign the load over the frame as a point load. Check this option. Once you click over that, so under the live load pattern, see the gravitational direction is already given. It is what? Gravitational direction. So you don't need to worry about minus and plus sign. Hello.
Yes, sir.
Yes,
It
sir.
already has given gravity. Previously when you are going to practice, suppose select the joint, go to assign, go to assign, go to join load, go to force. See, in this case, is there any is there any there is any motive means intention, like there is no any option that defining the load is going to be assigned under the gravitational direction. Is there any?
No, sir.
No. That's why while assigning the value, we are going to put the minus sign to show the load is vertically downward. That's why. But when you look at this window, sorry. Okay, go to file, sorry, go to frame and go to assign, go to frame load, go to point load. Now in this case, you will get then option, the load is going to be assigned under the gravitational direction. That's why you don't need to worry about the sign. Now that these three options are same, there is no any change, it is okay. If you want to assign the force, so assign force will be checked. If you want to assign the moment, so moment will be there, first thing. Second thing, what does mean by these all options? Okay, so here relative distance from end I, relative distance from end I, actually in this case what software is dividing your member in parts from like or you can say by percentage, distances in by percentage. So from 0 to 25.25, one fourth part, this is what this is
half.
no, it is a 0.25. So it is 0 to 0.25, 0.25 to 0.75, and 0.75 to 1. So it is little bit complicated to understand and assign. That's why I suggest that go with the second option. This is the absolute, at what distance and at what means what value you want to assign. Accordingly you can proceed. Hello.
Yes, sir.
Okay. So absolute distance from end I. Suppose horizontal beam is there, so it is I, left end, and right end is actually the J. I and J. Okay. So that's why absolute distance from end I from left side. So it is a single frame, single beam whose left end is I and right end is actually J. Hello.
Yes, sir.
Now select the frame. I want to assess. See, first option is in meter, second in kilonewton, means at what distance, how much value of the load you want to assign. Very simple. At a distance of 0.5 meter, I would like to assign the load of intensity. How much? Hello.
0.3 kilonewton.
Exactly. I would like to assign 0.3 kilonewton. Let's say simply apply. See, I have not assigned the minus sign. Why? Because already gravitational direction were considered. So simply apply. Is that all okay?
Yes, sir.
Very simple. Now, very interesting. I have to assign 500 kilonewton to the same frame, but at another distance point 0.5 plus 0.7 will become what? Always you have to measure the distance from end I. Getting or not?
Yes, sir.
Yes, sir.
Okay. So it will be what? 1.2. Just go back to your ETABS and see. It is 1.2, 1.2, and at a distance of 1.2, the intensity of the loading is 0.5.
0.5.
Change it to 0.5. Look at it. Look at this image and this figure. Your model. Okay. 0.5. Say apply. Sorry. Why this pop-up we are getting? Can you guess?
No object is selected.
Member not selected.
Member is not selected. Frame
Yes,
is not
good.
selected.
Member is not selected. Where you have to assign, that is not selected. So what software will do? Okay. So select the frame. Now say apply. Very seriously, just look at this. Say apply. What happened? New load has been assigned to this frame, but the previous one is deleted. That is removed.
Okay.
Then what?
That's fine.
Why?
Replace is it
Replace
replaces
existing
the
load.
existing load.
Exactly.
Replace
The option where it is checked, because the same assignment, if I am going to change the load format, Okay, one mistake we are doing here. Dead load. It should be what?
Yes. Live load.
Live load. Okay, okay, that we will correct. Yeah, okay. See, replace existing load option is there. If you are going to assign in the same load pattern for the same member, for the same load pattern, for the same member, if you are going to assign the load with the replace existing load option, so previous load will be deleted and newest load will be added. Latest one will be added. That's a problem. So undo this step. So 0.3. Okay. Undo this step also. Okay. So make it as what? Live load
Live.
at a distance of 0.5. The intensity of the loading is 0.3. Now say simply apply. So and select the frames. Simply apply. Second case, at a distance of 1.2 and the intensity of the loading will be 0.5. Select the frame and what we have to do? Can you guess?
Add to existing load.
Yes, add to existing load. Let's say simply apply. So new load will be added here, and I now at this time I can assign the load over the join. So if I want to assign the load over the join, can I proceed with this dialog box?
No.
No, because that is what joined assignment, and we are working with the frame assignment. So okay, we are working. Select the frame at a distance of 2 meter. How much intensity of the load is there? Yeah, 0.8. Just put it as 0.8. Let's say with add to existing supply. See, is it right or wrong? Akhila?
Right, sir.
Okay. Chandradev, Akhilesh sir, Ritesh.
Yes, sir. Yes, sir.
Right, sir.
Okay, good. Okay, so after having this, see, just perform the analysis. Okay, check your model. Actually, before of assigning, we have to check, but it's okay. Say simply okay. Yeah, no any kind of error. Right click, set grid system visibility. So grids will be off. Now perform the analysis. Okay. Now after getting the deformed shape of your structure, just go to display, post stress diagram, frame pair and spindle. Now I would like to see what? I would like to see
Live load.
under the live load. I want to use the shear force, automatic, fill diagram, fill diagram along with the values. Say apply. Hello.
Yes, sir.
Yes, sir.
Now at this time you are having the result like this. Shear force diagram. Okay, so now in this way you can see the shear force, but if you want to see the more elaborated result, just right click over the frame. So previously when we have modeled the beams in part, so we are getting the result for each individual parts, right or wrong?
Yes, sir.
Now here the benefit of modeling this beam as a single line, single element, so we will have the result in once. So on left hand side, so 1600 and 2.35 means 2350 and 1600. 2350, 1600. At the point B, see 1550 and your shear force is 1300. But how I can take my cursor here exactly at 0.5? Can you guess? Hello. So here you can put the value directly 0.5. Say enter. So now you will have the result. See 0.5 for the left side is showing. If I am taking my cursor on right side, so it is showing what? 1300. So it's right. Now again go to 0.5. Say enter. So here 1550. Now come to this side directly. Here 0.8, 800 kilonewton. Here it is what? 800 kilonewton. And intensity of the movement is 640. Just go back and at a distance of 1.2, say enter. It is what? 640. It is right or wrong?
Right, sir.
Okay. Now close this. Unlock this model. So this is all done for validating your result. Now next example, we have to model this beam. Hello, which type of is this beam?
Fixed. Huh?
Hello.
UDL load and point load.
No. What type of this beam?
Cantilever beam.
Cantilever, sir.
Cantilever. Okay, good. Now another question is what? How many grids will be needed?
2 grids.
2, sir.
Start and end. That's it. Hello.
AND.
Yeah.
Yes.
Just go back. File. Say new model. Say apply. Okay. In x direction 2, in y direction 1. Here, what is the distance? Find out this total distance. Hello.
2 meter.
2 meter.
2 meter. Change it to what? X direction 2 meter. Y direction will it be 1? And no need to. Is it needed to go to custom fast?
No, sir.
No. Then story will be 1 only. Make it as 1, 1, 1 all. Go to it. Grids only. Say simply okay. Now close this. And we will like to have the elevation. Go to elevation along grid first. Say simply apply. So we'll have the grid first. Elevation along the grid first. Now go to draw or take the frame. Now close this from this first point. Really move to this point. Okay. So really move to this point. Then right click to off this continuity. Then say off. Drag it from left to right. So the joint will be selected. Go to assign. Go to joint load. Go to restrain. And check this fixed option. Say apply. Now the joint. We have assigned the joint to the. We have assigned the fixed support to the left end. Now it is what simply supported. So first we have to assign the point load. Hello. Can anyone guide me how I can assign the point load over the frame? Fast. Don't take much time.
Assign.
Any of-
Go to assign, sir. Assign frame loads.
First select beam, sir.
Very good. First select the frame. Then tell me.
Go to assign.
Okay. Fast.
Frame load.
Sorry. Frame
Frame
load.
load.
Frame load.
Okay.
Distributed load.
Sorry.
Distributed load, sir.
No. First I would like to assign the point.
Point, sir. Point load. Then.
Point load. Okay. Then.
Live load.
Okay.
Then make it 0.
Absolute distance.
Absolute distance.
Okay,
From
then?
end I. Then
Point.
point 1.5, sir. At a distance of 1.5.
At a distance of 1.5. Then.
Load is
2 kilonewton load.
2 kilonewton.
2 kilometers, sir. 2.
Okay. Then.
Apply.
Apply. Very good. Okay. Now next, how you can assign the uniformly distributed load? The same procedure. Select the frame. Go to assign. Go to frame load. Go to distributed. And in distributed, for the live load pattern and forces, gravity, everything will be same. Again, go to absolute distance. Actually, see, very interesting. If you want to assign, see, it is not needed to practice with this trapezoidal load option right now for this example. Why I'm saying this? Because see, the beam is subjected to uniformly distributed load. First condition is what? The beam is subjected to uniformly distributed load. That's why it is not needed to discuss this first. Second, the beam is subjected to uniformly distributed load for full of its span. If it is subjected to full of its span, then only then also you don't need to discuss this. Where to discuss this? We will take it in the next example. But if the situation is that the beam is there which is subjected to uniformly distributed load, and another advantage is what? It is subjected to full of its span. Let me know. It is for full of span or not? Same intensity
Yes,
of the
sir.
loading.
Yes, sir.
Okay. So that's why what option we will follow? Except of discussing this, come to this directly and put your requirement value. Tell me. Hello.
Yes, sir.
Yes, sir.
How much intensity?
1.5.
1.5.
1.5 in kilonewton per running meter length. So 1.5 let's just simply apply. So okay, I think okay, let's say apply. Hello. Okay, 2 kilonewton point load is also there, and 1.5 uniformly distributed load intensity of the loading is there over the beam. Getting or
Okay.
not?
Yes, sir. Since it is uniform load, so we shouldn't opt to trapezoidal load option.
Yes, that we don't need to practice.
Okay.
When to look at that, I will let you know in the next example. Okay.
Fine, sir.
Hello, is that all clear?
Yes, sir.
Yes, sir.
Okay. This will be very important when you have to assign a wall load over the beam in the real project. Okay. There we will practice in detail. Now, after, is there any another load? Tell me fast.
No,
No, sir.
we have
No,
applied
sir.
all the loads.
Okay. So coming back to your software and go to check your model, go to analyze, check your model. And every time we miss to check our model after the modeling. Okay, but you should do this after completion of the modeling. You have to check the model. Okay, now
Okay,
then
sir.
perform the analysis. Now we will have the deformed shape of your structure. If you want to see the animated shape, you can click here. So animated shape of structure you will have. Say stop, then go to display, and go to force stress diagram. Go to frame pier spindle, and under the lie load pattern, I would like to see the shear force first. Say apply, and I would like to have these show values also. The values will also be shown here. Shear force diagram. Okay, so just go back and look at this. How much shear force on left hand side? 5 kilonewton. Look at your result. It is 5 kilonewton or not?
Yes.
Yes, sir.
Yes, sir.
It is 5 kilonewton. Okay, at this point, if you want to have more elaborate result, just right click over the frame. So we'll come to this kind of window here. See shape of the diagram, whether it is right or wrong. Look at this. In a reverse, it is inverted form. Hello, it is only above the grid line, above the baseline. It is below the baseline. Both the things are same. Hello,
Yes, sir. Right, sir.
that is only
Okay.
the way of presentation. On left side 5 kilonewton. Here on left side minus 6 kilonewton, sorry, means negative kilonewton meter, because hogging moment will be there over the fixed support of a cantilever beam. Okay, so here 6 kilonewton meter and here 5. It is correct. Now at a distance of 1.5 meter, intensity of the shear force is 2.75 and moment is 0.1875. At a distance of what? Scroll value. At a distance of what? 1.5. Say enter. So you will have 2750. It is 2.750.
Yes.
Okay, and moment is what? 1875 Newton meter.
Kilonewton per meter.
1875 Newton meter. Is it right or wrong?
Yes, sir.
Right, sir.
Right.
Okay, so results are validating.
Validated.
But deflection picture is not clear. A cantilever free end should have the maximum deflection, but it is showing 0
Where, sir?
in the deflection chart. The free end should be having maximum deflection, but it is showing 0 deflection free end.
No.
And at joint J?
Yes, please.
Yeah, it should be. It's actually right. See, sir. See, sir. Hello.
Now it's correct. Yes.
That is what related to beam end and related to frame minimum. I'm not getting. I have to study about it. Okay, sir. I will let you know.
Yeah, absolute is correct. Right.
Absolute. See, it is giving right. Okay.
With respect to the overall structure, yes.
Yeah,
Correct.
yeah. Okay.
Correct, sir. Thank you.
Okay. Now close it. Now next, okay, this example is now over. Next to that, we have to practice for this. Can you tell me how many grids line we have to take for this kind of beam?
3, 4,
3.
4, sir.
4,
4, 2. Anyone
4.
else? Hello?
4, sir. A, B,
4.
C, D.
Okay. Ritesh, what do you think? Sachin, what do you think? Akhilesh sir?
4
3,
grids.
sir.
4. Akhilesh sir, what do you think?
3, sir.
3. Okay. Anyone else?
Yeah, it depends on the method we choose to, whether we want to apply on a member or on a single beam.
Sanskruti, what do you think?
3, sir.
3. Good, good. Those who said 3, they are right. Actually, see, 1, 2, and 3 that we have to take. Why? Because see, for assigning of loads, if you don't have join, it's okay, no issue. For assigning of load, if you don't have join, then okay, no issue. You can assign the point load over the frame. But for the case of assigning this support, there is no any option except to have the joint. Hello.
Yes, sir.
Yes, sir.
So for that, anyhow you need to have the joint. So it is what continuous beam. It is one beam which is supported on two supports, and it is going to be continue or overhang span is there. Okay, so that's why one grid will be here, one grid will be here, and to get the end point, we need to have the one grid here. So totally three grids are needed to have along x direction. So go to ETABS, go to file, go to new model, and just click over this, and with third option just say simply okay. In x direction number of grids will be 3, in y direction as usual 1. In x direction what is the span? So means it is a non-uniform, so let it to be as it is. In y direction it will be 1, and go to custom grid, go to editor, and go to grid data as spacing, second option. Now first at a distance of what?
10 meter.
10 meter, and second one?
20 meter.
Yes, it is 10 meter and is 16 plus 4, 20.
20.
Just go back. 10 and 20. Total overall is actually 30. Okay. Now let it to be as it is. Take some dark color. Let's say simply okay. Let's say simply okay. And number of stories I need to have 1, 1, 1. Let's say all will be okay. Go to grids only. Say simply okay. Now close this window and go to elevation. Along the grid first, I would like to see the elevation. Say apply. Now close this. Next is what? Take the frame. Now close this. This is the first point. Freely move to this point, and now come to this point. Okay. Now can you wait for 2 minutes? Hello.
Yes, sir.
Okay. So how to model the frame like or beam? Just take the frame, this frame element, line element, close this dialog box. From this point, this is the first point. Freely move to this point. Now coming to this point. Okay. So this beam has been modeled. Now the support is present at this point, at the mid part or intermediate part. Drag it from left to right, so you will get the joint. But yeah, if suppose I'm trying to get the joint in between for this continuous beam, so I will not be able to get the joint. If I'm taking the beam from this point to this point continuously, some of you may think that like why we are not taking the joint beam from this point to this point, and then why we are not assigning the support to this at the mid. Suppose I have to assign the support at this point. Is it possible for me to get the joint? Hello?
No, sir.
No. That's why we are going to break it. So joint will be there. Go to assign and joint, because support will be assigned to only the joint, not frame. Remember. So go to joint, go to restrain and fixed. Sorry, what kind of support is there? Let me check. What? Roller.
Roller
Check
support.
this roller one. Say apply. On right hand side, it is the hinged one. So take the hinge support and let's say simply apply. So on left it is roller, on right it is hinge. Next, come back to your ETABS. Sorry, this question. Now, on left overhang part, what type of loading is there? Uniformly varying load is there. Uniformly varying load is there, whose left end intensity of the loading is 0, and on right hand side at a distance of 10 meter, what intensity is there? 2 kilonewton per running meter length. Hello?
Yes,
Yes,
sir.
sir.
But it is what, frame load or point load? Tell me.
Frame load, sir.
Frame
Frame
Ashok
load.
sir. Sanskruti.
Frame load, sir.
Sabia, are you there? Hello. Sabia. Okay, it is the frame load. Select the frame. Go to assign. Go to frame load. Go to distributed. Now, under the live load pattern, at this time, this option uniform load for the full span will not work. You have to go with the trapezoidal load. And as similar that of previous case, you have to practice with the absolute distance. Check the absolute one. At a distance of for this frame, it is left end I and right end as J. On left end at 0, at left end at 0, what intensity is there? Tell me fast.
0.
0. So here it will be 0. At a distance of 10 meter, the intensity of the loading is 2. Let's say simply apply. See, is it right or wrong?
Right.
Very simple. Now, come to this frame, select the frame. Now, uniform intensity of loading is there, but just tell me, this intensity of the loading or this load of 2 kilonewton, same intensity is there. 2 kilonewton uniformly distributed load for this second beam. Okay, this beam, it is for full of span or means part span. Tell me.
It is for
Part
16 meter.
Only for the 16 meter. Okay, so can I go with this option?
Which option?
This one?
No, sir.
No.
Make it 0. Make it 0. Make this all as 0. Okay, I'm doing this. Intensity is what? Same. 2 kilonewton.
Yes,
Step
sir.
2. Say apply for this frame. The problem is what? It is going to assign full of. It is for full of span. Is there any option to define only for this specific length? I want to have the assignment. Is there any?
Relative distance from
No. Is there any distance here?
No, sir.
No.
So that's why it will not work. Undo. Okay. Select the frame. So go with this. Make it as first 0. Go with this option. And for this frame, okay. And see. At 0. Now here you may think that it is not 0. It is what? 10 meter. Then it is going to start 16 here. So going to become 26. It is not like that. Because it is what? Another frame. Hello.
Okay. Two separate
It's
frames.
now it's left hand is I and right hand is J. It's the another frame. Remember.
All right, sir.
Okay. So clear this all. Come back and at 0, what intensity is there?
2 kilonewton running meter.
2 kilonewton. At a distance of 16 meter, what intensity is there?
2 kilonewton.
2 kilonewton. Now simply say apply. But see, replace existing option is there. So previous load will be.
Will replace. So
So what option should be there?
add to existing loads.
Right? Hello.
Same, sir.
Add to existing loads.
What it should be?
Replace existing.
Add to
Add to
existing loads.
existing. So those who are saying add to existing, they are wrong. Why? Because it is another frame. There is no any relation with this one, Nazia.
Yes, sir. Yes, sir.
Hello.
Got it,
Nazia.
sir.
Yes, sir.
Not getting?
Yes, sir.
Not getting?
Got it, sir.
Got it? Okay.
Yes.
So it is another one. So there is no
Yes,
any
sir.
relation. Okay.
Yes,
So
sir.
yeah, say simply apply. Replace let it to be. Say apply. So this is done. Yeah, previous one is also available and new one is also available. Okay, so this is done. Is there any another load? Let me know.
No.
No. Now perform the, okay, check your model again. Go to analyze, check model, select of all, say okay. Before of assigning of the load you can check, after the assigning of load you can check your model, no issue, but better is that go to check your model before of assignment. Otherwise if you want to, if you need to delete anything after assignment, so what will happen, means if suppose any kind of modeling error is there, or if you want to delete something from your model, so load will also be removed and your element will also be removed. That will be the problem. That's why first try to correct your model, then go to assign the load. But if you are working at expert level, so at that time anything you can do. After the assignment also you can check your model. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes.
Now after this, just perform the run analysis. It is asking to save your model. Say apply, sorry, save. So this is what, see, the form, the shape of your structure. It is what? It is actually the cantilever part. And it is what the supported at both of ends. That's why having the more deformation at the mid part. And it is having the it is actually the cantilever one. So means overhang portion, so it is having more deformation at this end. Right? Hello.
Free end. Okay, at free
Okay.
end it
I
will
want
have
to
some
see
more
the
different
movement. So which axis I need to look? Hello.
moment.
3, 3.
3, 3.
Okay. So can anyone guide me how I can see movement?
Display,
Display
Okay, display.
frame,
force stress diagrams.
Okay,
Frame pier spandrel.
okay. Then
Moment 33 is already checked. Live load, yes, we
drive.
have to select live load. Then
show
show
value at
value.
controlling point. Say simply
Yes,
apply.
applying.
So you will have this kind of result. Hello. Is that all clear?
Yes, sir.
Understood or not?
Understood.
Yes, sir.
Okay. So see, this is what the value at the mid of the span 75.1 5167 movement. Let me check. 75 point something. Is it right or wrong? Hello.
75.5
Over the support
point
33.33. Over the support 33.33.
over roller support. It's
Over the
some
support 33.33. Is it right or
yes,
wrong?
right, sir.
It is what negative
33.33.
moment, because it is what cantilever. It is what
Cantilever,
cantilever. So you will have the negative moment like this. So your software is also showing
yes.
negative moment. The red color is showing the negative. Only is this showing upside. Okay, so that's okay, no issue. Upside negative moment, and at the mid of span sagging moment is there. Hello. Yellow
Yes,
color
sir.
is showing sagging movement, red color is showing hogging movement. And always remember, over the support, over the continuous beam, in case of continuous beam, obviously at the intermediate span, at any
At the
point you will have
supports.
the support. Suppose column is there. Okay, so over the support you will have always the negative movement. So here over that support you will have the negative movement, and here at the mid of the span of
Mid of
any
the
beam
span.
you will have the positive tensile movement, positive movement, sagging movement. Getting? Hello.
Got it, sir.
Okay, good. Next, come back. So yeah, it is movements are actually matching. Now at a distance of 16 meter, I want to see the result at 16 meter. How I can see that? 60 somewhere here I have to check. Can you tell me how I can
Right
see?
click, right
Right
click.
click over the member. So these are full means analysis results are available. Scroll value at a distance of 16 meter for this beam. Enter. So how much value? 113 is the shear force. 44.53 is the moment. So okay, shear force is not given. Okay, forget that. Here the moment is 44.52.
5.5.
And what so in software you are getting?
44.553.
Right or wrong?
Right, sir.
Okay. So this is the way how you can see whether your result is right or wrong. Understood?
Understood, sir.
Is that all clear?
Yeah.
Okay. Now close this and go back to your this format and come back. I have to is it visible?
Yes.
So can you tell me how many grids will be needed? Actually the by points it is showing here, it is what the supports actually. What? It is hinge support, it is hinge support, and it is what? Roller support. Over the continuous portion always you will have the roller support. Okay, remember. Tell me how many
Two,
grids
two,
will be
actually.
needed?
3.
Two.
Is 3, sir.
3.
3.
Ashok sir.
Three. Sorry, free hand. Yes.
Okay.
Yes.
Go to ETABS, go to file, go to new model, say no, third option. And next direction 3, y will be 1, and rest of all will be in x direction. Is then a repetitive distances? Yeah, 2 meter is there. Put it as 2. Repetition of length is there. In y always 1 will be there. Go to custom, go to edit grid data, go to
Display grid data,
display
add
grid data
spacing.
spacing. Here first 3 meter, then 2, then 2. Sorry, first 3 meter and then 2 plus 2 will become what?
4,
5 plus 2.
5.
No, sorry. Actually, the beam will be there from this end to this end. So it is 3
Oh,
plus 5.
5.
3
Yes, sir.
plus 2 is 5. First put 5, right? Then 2. Am I right or wrong?
Right, sir.
Then 2. Okay, so total 7. In y direction, nothing will be there. Some dark value of the color. So, okay. Okay. Grids make it as only one story additional above the base. 1 meter, 1 meter. So simply grids only. Let's say simply okay. Once you click over the okay, so it is what your plan view. I would like to see the elevation along the grid first. Go to elevation along the grid first. Let's say simply apply. And I want to work over the at a story first. Go to frame. This is the first point. Close this. This is the first point. From here to here it will be the second one, and it will be here to here second one, and this will be the one, right? Hello.
Yes, sir.
Okay, now next drag it from left to right. Here the support is there, which is I told you it is the hinge, and internal one we have to consider a roller. So on left hand side go to assign, go to join, go to restrain. Here we have to assign the hinge support. Check the hinged one, say apply hinge support. At the intermediate span, intermediate point, here we have to assign what? Roller support. Check the roller one, say apply. So the roller support has been assigned. Now what about the loading? How you can assign the load? Hello.
Assign frame load.
Okay.
In,
First of all, select
go to
the frame.
assign. Select the frame.
Select the frame. Okay.
Go to
Go to
assign.
assign.
Go to assign.
Frame load. Select
See
frame loads.
first see how many types of loads are there for this A to
UVL
B
and
beam.
UDL.
Sorry.
UVL, point load, and UDL.
All three types of loads are there. Hello.
Yes.
So first we have to assign the point load. Accordingly guide me.
Go to
Point load frame, then
frame loads at a distance
frame load,
of
then
Point.
point,
point
then
load.
Like
Absolute distance from absolute distance from
okay, then
end I. Absolute distance from end I, sir.
yeah, that I have checked.
Hello.
That I have checked. Hello. Okay.
Yes, sir.
Absolute distance from end I is checked. Next.
Next, we have to give that distance till where that point load is coming.
At what distance from end I?
At 3 meter, 10
Okay.
kilonewton point load is
How much kilonewton? 10.
10 kilonewton.
10. Okay. So simply apply. The load has been assigned. What next kind of load is there? Is there any another point load? First check. So that we will complete first. Is there any another point load?
No, sir.
No. Now I can off this window. Then another one is the first we will assign non-uniform load. So select the frame. Uniformly varying load. Select this. Go to assign. Go to frame load, and under the distributed one, and go to live load, and under the live load, with the uniformly varying load, absolute distance from end I, and at 0 it is at 0 what intensity is there?
At 0 it is 18 kilonewton.
18 kilonewton per running meter length.
Yes.
And
18 kilonewton.
at 3 meter what intensity is there?
0.
At 3 meter it is what? 0. Let's say simply apply. Is it right or wrong?
Right, sir.
Right. Now next, select the same frame. Now at this time I have to assign what?
Uniformly distributed load.
Uniformly distributed load. But now can you tell me it is for full of span or part of span?
Part of the span.
Don't consider this one. Don't consider this one because it is the another part. Here the one beam is up to this point, and other beam is from starting from here and ending here. Okay. So for this beam, this uniformly distributed load is a part load or full of span beam load? Tell me.
Part of the
Part
beam.
of the beam. Okay. So how much intensity is there? Intensity is same. 2 kilonewton per running meter is running meter length. Okay. So it is starting from 3 meter and it's going to end at 5 meter. Okay. So go back.
Yes, 5 meter.
Now same frame at starting from
5
3
meter.
meter. What intensity is there?
It was 10.
Sorry.
0.
0.
Sorry. Tell me.
At the end of 3 meter, it is
2 kilonewton.
yes,
And at 5 meter, how much it is?
2 kilonewton.
2 kilonewton. Can I say apply?
No, sir.
Yes.
No, add.
Add to existing load.
Yes, it should be add to it because you are working over the same frame. So it will be vanish if you are not going to check this add option. Say apply now. Is that all okay?
Yes.
Now select this full of frame and make all of these as 0, 0, 0, 0. No worry about 0. And just here put as 2 intensity for full of span. So simply apply. So simply see all kind of load we have assigned as per your example. Is that all clear?
Yes, sir.
Okay. Now go to analyze, go to check model, select of all of these, check these options, say okay. So we are going to check our model. Model has been checked. No warning messages were generated. Now close this. Clear? Hello.
Clear.
Yes, sir.
Next, go to perform the analysis. Go to analysis and just perform the run analysis. So your analysis will start. Just click over that. And it is asking to save your model. So change it to 6 number of model. Say yes. Now you will have the deformed shape of your structure. Just click over the start animation. So it is going to animated. It is going to be animated, and you will have this kind of response. Okay. Then go to display. Go to force stress diagram and go to frame pair. Under this option, under the live one, I would like to see the shear force first. So simply apply. Now coming back to your question, see this kind of result we are having. On left hand side, it is 25.6.
25.6.
Just right click over this frame on left hand side 25.6, right or wrong?
Right, sir.
For this frame, 5 meter frame on right side 15.4. It is 15 point. Yeah, actually, yeah, here it is 15 point.
4 at the distance.
Okay, it is
Yes.
what, like this. Just go back. So this kind of result you are having. Okay, the moments are on right side minus 4 kilonewton meter. On right side minus 4 kilonewton meter moment is there. At the mid of the at zero shear point, how much maximum moment you are getting? So zero shear point is there. The distance is not actually given. Okay, so at this distance what 23.44 you are getting. So 23.44, 23.09, just move to this side. 23.44. Okay, at the midpoint we will get. Okay, for zero shear, if you are succeeded to get the point of zero shear, so we will have the maximum moment at that point, 0.06. Yeah, 0.00019. So almost 0. Here the moment is what, 23.32. In your 23.32, it is acceptable or not?
Yes, sir, it is.
Okay, so in this way you can check the shear force and bending moment diagram for your analyzed beam, and you can validate the result in this way. So close this window, just go back to this and just come down, and there's no any another, only one example is there. I'm going to left it for your practice, for your exercise. Okay,
Okay, sir.
so see, first try to understand the problem. Okay, the result of this problem will not completely match as per the above cases. Why? First of all, try to understand these circles. So it is not needed to assign. This is actually this image actually the next part of next level of solution, or this is a design analysis result actually it is. So this value will not be there. This upward reaction will not be there. Okay, only you have to assign left end as fixed, intermediate as roller, and right side as fixed. Okay, now these movements will not be there. You might be means solved example, means solved a beam. You have analyzed the beam by manual calculation in your academics by moment distribution method. Have you remember that?
Yes, sir.
For indeterminate beam, actually it is indeterminate beam. How many reactions are there? 3,
There are 3,
Eight-
3,
eight
6,
reactors.
6,
5,
8,
and this 3 again. How many it will be?
7, 3, 3,
8.
6,
8 reactions. Available equilibrium equations, how many?
3.
3.
Three.
So can I solve this problem by the normal equilibrium equations?
No.
No, it is indeterminate. So there are so many methods of analyzing indeterminate beams manually, like Castigliano's method, moment distributor method. Hello.
Yes, sir.
Any other
Compatibility
name?
methods.
Sorry.
Compatibility method.
Compatibility method, moment area method.
Yes.
Any other one?
Conjugate beam method.
Yes. Conjugate method, I think. Am I right?
Yes.
So those all methods are actually for non-linear. Sorry, for indeterminate beams where your means support reactions are more than available equilibrium equations. So that is the same case here. So this problem has been solved by moment distribution method, and you means if you can recall, so you can understand, in moment distribution method we are manipulating the results. Hello, manipulating the values by some carryover factors, right or wrong?
Yes, sir.
Okay, so after following that method of analysis and design analysis, we will have this result. So it will not exactly match your result. Okay, so up to some differences will be there, that will be acceptable. Will you practice this or not?
So we have to practice without this moment, without applying these
Yeah,
moments.
actually it is the next part. After
Okay.
dividing it, then we are putting these values.
Definitely,
Only question is what? frame is there, and supports are there at all 4 points. This uniformly distributed load 50 kilonewton per running meter.
Yes.
For this middle part 4 meter, and upper here it is a point load, here it is a point load. That's it, nothing else.
Yes.
Hello.
Yes, I got it. There.
Sanskruti, clear? It has. Now this done. So this exercise of validating your results is now over. Okay. Shall we proceed for the next exercise? Hello.
Yes, sir.
So may I know what things you have learned through this exercise in short?
Assigning load, sir.
Assigning of load. Okay, fast.
Different
Ritesh?
types of load.
Sorry.
Different types of load.
Different types of load and methods of their assignment.
How to check the shear force and bending moment diagram.
Very good. Most important, how to see the shear force and bending moment diagram. Good, Bhushan. Good. And axis consideration and axis understanding, Bhushan. Am I right?
Yes,
Yes,
sir.
sir.
Very good. Yes, Patil. Sanskruti, any point what you have learned from this exercise?
How to assign loads and how to check it.
Okay. So all types of loads you have learned how to assign over the frame or over the joint. See, always joint load you learn, frame load you learn, uniformly distributed you learn, and uniformly varying load also you have learned. Only what load is remaining? Area load that will take in real project. Okay. So now go back to your next exercise.
Yes, sir.
Now, the objective of taking this next exercise is what we have to understand some basic settings in ETABS software for the smooth and easy modeling. First, we are going to see some important commands in the ETABS software for the smooth modeling and fast modeling in the software. So, setting, modeling, editing, some important commands we are going to see that will help us to proceed for the and that will make us to ready for the next real life project, that will make we all ready for the next real life project. So important things we are going to cover, so don't miss any point. Very detailed discussion will be there for important things. So just go back to your ETABS and see for the see setting, editing, modifying, and all important commands of the ETABS software for the smart modeling in ETABS software without of having modeling errors and without of making your model as much complicated in respect of it's a view, means how you can easily model the beams. What things you need to set before for ease of modeling of column, for ease of modeling of the beams, and actually preparing your entire model. Hello.
Okay.
So the most important things we will learn from this exercise, and after this all commands completion of all this command, you will get one means you will feel you are at the next level of working with the ETABS software. So you all are ready? Hello.
Yes, sir.
Okay.
Yes, sir.
Okay. Number first, different file formats of ETABS software, their importance and application. Now, at the in the first session of this training, first day of this training, I told you there are different versions of the ETABS software. Have you remember that or not?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
So they are so different. There are different there are different versions. Like in market, actually 13 version was also there, but that is outdated. In nowadays, if you go out and if you are trying to look, so oldest version that is in use, that is 2015. Hello. 13 was also there and it was in practice, but that is what not nowadays it is present anywhere.
Okay, sir.
Yeah, 15 version is there. Somewhere you may get, otherwise you will get the 16 version, otherwise you will get 17 version, otherwise you will get 18, 19, 20 likewise. Okay, so there's no much great difference between the, there's not much great difference between the version. Some points are there that we will take. Okay, see. So suppose what difference will be there if you are working with the, if two persons are working with different versions of the ETABS software. Okay, so whenever you are going to work with the ETABS software, and if suppose two persons are there where they are practicing with different version, person one is working with person first is working with 2015 version, and the person two is working with version
2019.
2019. It is going to person 2 is working with the version 2019, person 1 is working with the 2015 version. Okay, now suppose, okay, some basic settings, some commands, some user interface obviously will be different, but that user interface will not much matter in your execution. If suppose I am going to change the color of this window, whatever you are what color of this window, hello,
White.
white.
This is
If
white.
I am going to change, suppose this is 19 version, I am going to I will give you 2022 version, and that is having everything is same, only the color is different. This window is having the red color. So what difference? Is there any difference? Is there any
No.
significant effect on your practice, in your practice? Tell me.
No.
No. So that kind of a change may be there. Okay, some important settings may change, some basic settings may change, some icons may change, so that doesn't matter. But yeah, something, if it is some changes may be there between 20 to 2015 to 2019, that having the significant effect. What are those? We will see. But amongst them, the most important thing is what? The files. There are three more important types of the files, like dot, dollar, et file. Hello. Second one is the dot edb, edb file, and dot ebk, ebk file. Hello.
Yes, sir.
These three files are very important whenever you are going to create any model, any version. Okay, any version. If you are going to create a model and going to analyze it, or you are going to save it, so in the base folder, so suppose ETABS, suppose this is the model G+5. So this much these are one model of files. There is only one model is there. Whose how many files are there? 1, 2, 3 backup files. Okay, so amongst these all backup files were saved by the software. These three files are very important. First one is .$et file. Hello.
Yes.
Second one is the ebk file, backup file, and third one is the most important is the edb file. That is what your model file. Hello.
Okay.
Model file, backup file, and what is the use of $et file, I will let you know. So this $et file, so these three files are very important, that is going to be saved on your base folder where your model is going to be saved. Okay, now suppose two persons are using the same version, versions P1 and P2, both of the persons are using same version like 19 and 19. Suppose the first person have to send the file to the second person for whatever the checking purpose and whatever. Suppose some of any of you are practicing with any project, and if you have to send the model file to me for checking purpose, and means it's a good thing if you are using the 19 version, I am also using the 19 version, no issue. You can directly send me the file as edb file, .edb file, you can directly send me. because why? Versions are same, so I will directly click over that file. I can open that file. Hello,
Okay.
no issue for me.
Hmm.
But if person 1 is using 2015 version file, 2015 version, and it is trying to send, or it is having to send the file to the second person which is using the 19 version, and if he is sending the file of EDB file, so that will not be useful. Why?
Beautiful.
Because it is the version change from
Okay.
lower version file. If you are trying to open in higher version, that will not be
Accepted.
accepted. When you are trying to open lower version file in the higher version, it is rejected. It will not be opened. First thing. Hello.
Yes, sir.
Second, if you are trying to open higher version file in the lower version, so what will happen? Tell me.
Rejected.
No. In this case, when you are trying the lower version file, trying to open in, higher version file, try to open in lower version, what will happen? If you are sending only the ADB file, so it will be opened. The file will be what? Hello.
Open, but they
Open. But problem
but
is
it
what?
will ask
Can you guess?
backup file.
Can you guess?
Due to difference of version, definitely it will ask for the supported version of files. So 19 will support .edb, but 2015 will not support edb. It will support the another
19 version
of
file. 19 version file. If I am sending to the person which is using 2015, the file will be open. Only ADB I will send, so it will be open. But the problem is what? Whatever the advancements are present, advanced options are present of 19 version model file will be rejected in 2015 version.
Okay.
Hello.
Okay, that will be not read by
All the
2015
updated
version.
things will be discarded in 2015 version, because that kind of provision is not available. Ashok sir.
Yes, sir. You are correct.
Correct.
Okay. In 2000, that all. For an example, very simple. In 2009, suppose I am taking any model which is high rise, and in this high rise structure, I have assigned the earthquake load. Can you tell me what is the latest version of latest code for the earthquake loading?
2018.
2016.
2016.
2016 ISO 1893 2016.
16.
Suppose while practicing with 2000, I am the second person using the 19 version for dealing this high rise structure. So I have assigned the earthquake load in respect of what?
1893.
1893 2016, because that
Yes.
code is available in 19 version. That
Yes.
code is available. That's why that is easy for me. That is the good thing for me. So I am using the latest version for latest code for the assigning of earthquake load. Now, here the assignment for the earthquake load. Now I have to send, by any means, I have to send this, by any reason, I have to send this 19 version file to the 2015 version, and I am trying to open. So what will happen? It is the 2015 version. Can you guess? In 2015 version, there will be the availability of 2016 code,
No.
right? Hello.
Yes, sir.
In 2015 version of ETABS software, there will be the
There will be
provision
the
of
older
2016
version
code.
of,
Will it be available or not? Tell me
code.
that only.
no, sir.
No. So what will happen when you are trying to open higher version in the lower one? So yeah, it will open the file. But while opening, it is asking that, yeah, earthquake load has been assigned by 2016 code, so it will be rejected. If you are saying yes, then it will be proceed. Okay. So all the assignment due to 16 version will be discarded in 2015 opened file. Getting or not?
Got it, sir.
Understood?
Yes, sir. When we'll proceed with some example, we will get a much clearer picture.
Okay. So sometime what? Higher version will be open in the lower version, but sometime it will not be open also. Sometime it will open, sometime it will not open. Then what? Then there is a role of dollar, hello, dot dollar ET file. Hello.
Yes, yes, sir.
Dot dollar $80 file. So in simple, if the version difference is there, don't bother about other things. Just do to share. If the version difference is there, doesn't matter lower version to higher, higher to lower. Don't think about that. If you are sending your file to the next person, send both of the file. Then it's his responsibility and its role to look at the file. Okay, so both
Yes, sir.
both the files, $80 files you have to send, and at the
If we
same
have
time
not,
what?
if we know about the files, then we can explain him that if your version is lower, you should open this file.
So that's what I'm telling. See, don't worry about that. If whatever the next person is using, you send both of the file, $80 or
Yes, sir.
EDB. Okay,
Yes, sir.
then it will be it's the second person look out to see which file is going to be open. Okay.
Yes, sir.
Okay, so both of the file, and backup file is just for have the backup, that is not having much importance, but among these two is very important. $80 file, EDB file. So if you are sending the file, so you have to send both of the file, $80 and EDB, both of the file you have to send.
Send.
Understood or not?
Understood.
Okay, so okay, we will practice with it. Suppose, see, okay, close this all. All of these trusses, beams and all models we have created in, these all models we have created in 2016 version. Have you remember that?
Yes, sir.
Hello. Now see what I am doing. Go to open 19 version. 16 version file I am trying to open in, hello, 19. Say go to open and see all these are available. So EDB model file is there, EDB. Suppose I am getting from another person who is using 16 version. Okay, suppose I am getting the file of EDB of this 006 model. Check this. I am trying to open in 19. Say open. See what happened. File is opened or not?
Yes, sir.
It is opened. No issue. It is open. Now the problem is what? No any other problem is there. Close this. Okay, in 19 I am going to save this file. Go to save this file, and here again I am going to save this file as 2019 version. I am just writing 2019. Save this file. Understood? Hello.
Yes, yes, sir.
Now close this. Okay, open 2016. Now same file I am trying to open in what? Hello. Now it is a 19 version file I am trying to open by the model file in 2016. Check these options, say apply. Okay. Higher version I am trying to open. What we are getting?
Error.
Decompressing file may not be valid. ETABS EDB file. What means overall it is not open.
Supporting the
all others are, see what no, it is not opening. Then what?
You have to go for $85.
Very good. Go to file with 16.1. Go to file. Go to import. See what is the procedure to open $80 file. Go to file. Go to import. Go to first one. ETABS.E2K file. This is actually the meaning of $80. Check this option, and now all the $80s are available. So suppose you are getting from the another person $80 file of 19 version. Check this one. Say okay. With this also it is saying that all the advanced things will be ignored that I have told you. Hello.
Yes.
Data from newer option will be maybe ignored. Are you okay
Yes.
with that? Hello.
Yes, sir.
Yes. Say simply okay. If some, yeah, some other also issues are there, then okay, then okay, then okay, then okay. See, all these are the advancements. Advanced options are available in 19. That is not available in 16. Hello.
Mm-hmm.
See, not your model but ready. Hello.
Yes, sir.
Understood or not?
Understood.
After importing file, suppose if you are getting any model from other one, and if you are opening in that in your model in your software, so look at everything, okay, to cross check, then proceed for the next step, okay, because most of the things will be discarded, right? Hello, is that all clear? First option. Now setting out quick access bar. Now we have to discuss how you can set the quick access bar. Just go back to ETABS, close this, go to file, go to new model, say no, go with the third option, say simply okay. Now we don't need to worry about these all, say okay, close this window. Okay. Now how you can set the quick access bar? Hello, how you can set this quick access bar? So go to option and go to customize toolbar. Is it visible?
Yes.
Customize toolbar. So draw this on left side. Look at this on left side. Draw quick access bar on left side and check this, so it will be available. So okay, select option,
Yes.
off this all. So when you install a ETABS software, so we'll have this kind of screen. Am I right?
Yes.
Now, how to set that quick access bar? So that quick access options are nothing but your these sub commands of this top main menu bar. Editing sub commands are these all are. View sub commands are these all are. Define sub commands are these all are. Okay, so that all sub commands we have to set on this screen for the fast flow, for the fast execution of modeling, analysis and design. That's why what, go to option and go to customize toolbar and check this one snap. So see here it is going to be added. Say okay. If you want to adjust it, just take your cursor here, dots are there, so take your cursor over that dots and take it and adjust it. Okay. Hello.
Yes, sir.
No. Then go to option, go to customize toolbar and go to assign joints. So all the assignment over the joints will be available here. See, load assignment option. It is what? Okay. Load assignment option. How we previously means by the long way we are proceeding, assigning of forces. Go to define, go to assign, go to assign, go to joint load. The same option is there or not? Look at this icon and look at this
Quick
icon.
access. Yes, sir.
Okay, so it's a quick access bar, quick access. Hello.
Yes. Yes, sir.
Okay, now go to define and go to section. Sorry. Go to option.
Options.
Go to option. Go to customize toolbar and go to assign frame. That will be all the assignment that you want to do over the frame. That will be there. Assign shell. That will be there. Edit will be there. A view will be there. Define will be there. Standard will be there. Design will be there. All commands will be adjusted here. Okay. Moreover of that, if you want to play with the positions of all these commands, so you can practice that like this. Take your cursor and put it here anywhere like this. Take from here, dots are there. When you see that, you will get, put it here like this. Take it from here to here, put it here like this. So it's your choice how you can set it.
We can arrange in the same way the above main menu bar is arranged, so we can arrange
As per your choice. Okay, there's no hard and fast rule. Understood?
Exactly, sir.
Is okay. So this is what quick setting of quick access bar. One more thing we previously have seen, Model Explorer. Model Explorer, sometime when you open the software and when you are going to prepare the grid, you will have that window here, Model Explorer. How you can make it enable? So go to option. In option, you will get the Show Model Explorer. Just click over that, so that window will be here. This is one option. You may say that why you are discussing this, sir, Model Explorer. So it will help you for the smart modeling and for the quick modeling. To save your modeling time, this Model Explorer option will help you. I will let you know in later exercises. Okay. Okay. So if you want to keep it to be present, so just or if you want to off this, close this and go to option. Again click over Model Explorer, that will be visible here. Understood or not?
Okay, sir.
Okay. Now close this. Go back to your option, setting of quick access. Is there any question about this quick access bar? Hello.
No.
No, sir.
Yes, Chandradev. Chandradev, is there any question?
Sir.
Is there any question?
No, sir.
Okay. Ashok sir, are you there? Sabia.
Yes, understood. No questions.
Sabia, are you getting?
Yes, sir.
Okay. Go back. Next. Removal or appearance of background grids of ETABS. Okay, background grids means what? Go back. Go to plan. Come to any level. Okay, go to file. Go to new model. Go to say new. Close this. Go to plan. Or take the 3D view. See, this is what background grids you are getting. These grids, small sections. Hello. If you want to off these grid lines, background grids. Hello.
Yes.
So go to view. Okay. Go to snap option. In snap option, see horizon. There is a detailed discussion about this snap option. So go to snap option and uncheck this horizon. So this background grids will be off. Say apply. It is off or on. Hello, is it visible? It is no longer will be visible. If you are checking this horizon, so it will be available. If you are unchecking this, say it will not be available. How you will come to this option? Set display option. Here is what set display option. What we are calling it a set display. In box, a right sign is there. So it is what set display option. Just click over that and uncheck this horizon. If you check this horizon, say apply. So background will.
नहीं, मेरे पास भी 190 रुपया था, मैं तो बोला अर्जेंट।
Hello. Okay. So background grids. Is that all clear? Very simple. Hello.
Yes, sir.
Horizon. Say apply. See background. Now it is available. Horizon background grids.
Yes.
Say uncheck this. So background grids will not be available. So it's your choice whether you want to work having this background grid, so you can work. If you are not willing to have this background grid, uncheck this, say apply. It is available in set display option, quick access bar. Otherwise it will be the view option. So go to view, and in view this set display option is there, and then go to horizon, uncheck and check your choice. Getting or not?
Got it, sir.
Ready. Okay. Removal or appearance of background grids is clear. Removal or appearance of plan grids, that we have seen. Plan grids. So these grid lines, suppose beams are there. Take the beam. Is it visible? Hello.
Yes.
Yes, sir.
Now suppose my model is like this. Okay, plan. Only try to understand the option. Okay, don't think that we are not getting how we can model it and all. Okay, that's another thing that we will take in detail later. Hello. Okay,
Okay.
suppose this is my model. So go to plan and come to any level. So how you can off after completion of the modeling. Okay, see, for preparing and creating your model, at that time we need to have the grids. Without of having the grids, you will be in trouble for creating the correct model. But after the completion of your model, go to plan, come to any floor level. Suppose I don't need to have this grid line. How I can off this A, B, C, D, 1, 2, 3. I don't need to have, otherwise it is creating the disturbance. So right click on the window, set grid system visibility, it will be off. Hello.
Yes, sir.
If you are right click on the window, set grid system visibility, it will be enable. It will be in view. Another way, go to view and here set grid system visibility, it will be off. Go to view, again click over that, it will be in view. Understood?
Understood.
Clear? Nazia?
Yes, sir. Yes, sir.
Okay, next. Now next, how to see the dimension of any line or length between the 2 points. Suppose, suppose you want to see the dimension between the 2 lines, suppose 2 points, suppose the one frame I have modeled like this. Suppose the beam is present here by any way, and I want to know the distance between the this point to this point. How you can see the distance? So go to draw and go to draw dimension line. Close this. This is the first point. Freely move to this point. So we'll have what? 15 point something. 15.60. But don't click over that. If you click over that, the dimension line will be fixed. Hello.
Yes. Yes, sir.
It will be drawn. You can't remove it. Hello. So but if just you want to know the distance, okay, suppose the grid lines are not there. Suppose right click set grid system, grid lines are not there, and then I want to know the distance between this point and this point. Distance between these 2 points I would like to know. So go to draw dimension line and close this, and this is the first point. Freely move to this point and let's see what is the distance.
8 meter.
Hello.
8 meters, sir.
Yeah, it is what? 8 meter. Right. If I am going to click here, so it is what? Permanently this dimension line will be drawn here. Hello.
Yes, sir.
Okay. So if you don't want to permanently to be present here, just go to draw dimension line and close this. Take the first point, freely move to this point, and now you will come to like this. You will have the distance. Understood or not?
Understood. Means we didn't require to click that.
Yeah, we don't need to click over this. Okay, just take your cursor at your required point. You will have the dimension. Then how to off this? See, go to draw dimension line. First point you have to click start point, and at this point I would like to know. So I take your cursor. So it will clear right sign will be there. Then 8 meter. I don't want to click over that. Just right click on your mouse. So this command will be temporarily continuity will be off, but the command will be active. Hello. So go to this select object to off the command to have the neutral action. Hello.
Okay.
Is that all clear?
Yes, sir. So we can even check with the help of move option, no?
Sorry.
We can, if we want to check just dimension, we can also check with the help of move option.
Move option?
Yes, sir.
Which one? No.
Means in move option, yes, sir. In move or replicate option, there is an option. Pick 2 points.
Are different. There is no any role in of knowing the dimension. What you are saying?
Means if we want to check just dimensions and we didn't want to draw dimensions permanently, we can even use that draw dimension lines option. We can even use this pick 2 points option in move command and
No,
replicate
not
command.
at all that is needed. Move command, replicate command, both the things are totally different. That's another concept. Okay?
Okay, sir.
Yeah. There's no any role in this concept, in this requirement. Okay?
Yes, sir.
Okay. Now, so this is the way how you can see the dimension between the two line. How you can see the dimension between the two line. So what is the procedure? Go to draw dimension line and close this, and this is the first point. First point, right click, go to first point and come to this side. So you will have this kind of result. Okay, 8 meter. This is the first way. Hello.
Yes, sir. Yes, sir.
What another way how you can see the dimension of this line, how you can see the dimension of this frame? Very simple, just right click over this member. Hello. Right click over the member, so all the biodata of this frame will be now available here. Very interesting. Hello. Now try to understand. If only the model is there, when you right click over the member, so you will have all the information about the element. Hello.
Yes, sir. Details.
Information about the element.
Member.
All the member.
Yes, sir.
Element. If you are having the analyzed model and you are right clicking over the member, you will have the analysis result or stresses or forces. Stresses means axial forces, shear force, bending moment, everything will come under the term of stresses. Hello. If your model is analyzed and you are right clicking over the member, if your model is designed and you are going to right click over the member, you are going to click right click over the member, so we'll have the all design report and design values. Hello. Same thing, but the same action, but the three different objectives is going to be solved. Hello.
Okay.
If model is normal model is there, not analyzed, so when you right click over the member, so you will get all the basic information about that particular elements, its geometry, its assignment, everything. Okay, it's basic assignments like property modifier and torsional, so many things are there. Then if the model is analyzed, then you are right clicking over that, so you will have the analysis result. Okay, and if the model is designed, then you are right going to click over that, you will have the design report and design result for that element. Understood or not?
Okay.
See what we are looking here, how you see the dimension of the element or dimension of the 2 points. So here the dimension of 2 points we are talking about, but we are turning into see the dimension of the element, length of the element. So right click over the member. Once you right click over the member, it will give the detail about this. So geometry, left end, two end. The frame is having the two end. Left end is I, right end is J. I and J, is it visible? Joint I is 4, representing by the 4 level. Joint J is represented by the 8 level. Hello.
Yes.
And I mean joint 4. Its ordinate is what? X, Y and Z. Joint J is also having X, Y and Z. So X is what? This point is 0 at 0. Y is 24 and Z height is what? You are at the level of 6 meter, second story. So Z point is what? 6 meter, right?
Yes.
Acha, previously we have seen that this point to this point, what is the distance?
8 meter.
8 meter. So in X direction, suppose this joint is at 0. So this joint in X direction at what distance?
8 meter.
Sorry.
8 meter.
So joint J in respect of your global axis, it is showing what? By the global axis. Try to understand, very interesting.
Okay.
The dimension we are representing by the global axis. Okay,
Mhm.
not getting. Hello.
Yes, sir. You may proceed.
It is what global axis in respect of global axis, and y is same in respect of global axis. This joint in respect of y, this joint in respect of y, either at same level or not.
Yes, sir.
Hello.
They are.
Sorry.
Yes, sir. They are.
Yes.
They
So
are at same
both
level.
y are 24, and x is at 0, and x is continuing and going to end at 8 meter. So it is 8. So length you will get along the x direction it is. So first it is 0 dimension, it is 8 meter. Take the difference of these two, 8 minus 0, you will get the length of this beam is what?
8 meter. Okay.
8 meter. Understood or not?
Understood, sir.
Okay. Now, and third dimension is your 6. Another way, close this. Now we will see everything very deep. In one point, we have to discuss so many things. Hello. So you have to stuck with me with my discussion. Hello.
Yes, sir. Yes, sir.
Okay, your concentration is very important. Okay. Now close this. Take your cursor here. So another way to know the ordinate of this joint is your concentration should always be on this side.
Yes.
What is the ordinate of this joint?
0.
0, 24 and 6,
Yes.
right or wrong?
Yes, sir.
Take your cursor to this point in respect of global axis
8.
24 and
global axis 8. Y is 24. And Z is 6 meter.
understood or
Second floor.
not?
That is.
That is the another
Yes,
way.
sir.
Okay, just right click over that. So these assignments, section property, the beam that we have model, what it's a section property. So it's a section property. It is ISLB, whatever the steel section 600 depth randomly we have modeled. Okay, so it's a section property. It's a property modifier, none. End releases, none. All its assignments means for this particular beam, what sectional property and assignments are, all will be available on this window detail. What loads are there? No any load is there. If I am assigning dead load, live load, that all will be available. Hello.
Yes, sir.
Okay, if I am perform the design, so design will be there. Means type of the design is a steel frame. It is what? A steel frame. If it is concrete, then it will be the concrete frame. Okay, close this. This is the way to see when you right click over the member and if it is not more analyzed, so you will have this kind of result. Hello.
Yeah. Okay.
All the
So,
definition.
sir, after designing, we will have from geometry to analysis to design. Means all these three details will be accommodated, right?
No. That will be there. Okay, everything you will get. See, normally model is there. So when you right click, so you will have this window. Now perform the analysis randomly. Say one. Same model has been analyzed.
Yes.
Okay, then right click over the member. Okay, go to display. First go to display and go to fourth stage frame result. Say apply and then right click over the member. So you will have the analysis result, right?
Yes.
Understood or not?
Yes. Yes.
Same option. Now perform the design. No, it is what the design result. Right click over the member. Sorry, perform the design. Perform the design. Then right click over. Let it to be completed. Right click over that. You will have the design report, design result. Are you getting or not?
Okay, sir. Got it.
Don't look other things. Only we have to understand what actually happening when you are going to right click over that. If simple model is there, normal view is there, right click. So all the biodata of your frame or element
Details.
will be representing here.
Yes, sir. Geometric details.
Geometric detail.
assignments or load
If you are
details will
performing
be
the analysis
visible.
and you are looking for the stresses, then you are right clicking over
Yes,
that.
sir.
You will have the result, analysis result. When it is design,
Yes, sir.
then you are right click over that. It will show you what design result. Are you getting or not?
Yes, sir. Yes, sir.
Understood?
Yes, sir. Accordingly, we will have the details.
Are you getting?
Yes, sir. Got it.
Do you know about this earlier? Hello.
Yes, sir. I know, but not in proper manner.
Yeah.
But but now it is much clearer.
Okay. Yeah. So that kind of all things will come to you. You know about the software, most of you. But the thing I will tell you that will not. That is what will make you create the confidence and will take you to the next level of using this ETABS software. Getting?
Yes, sir. Yes, sir.
Okay. So this is all about today, and we'll continue by tomorrow at same time 7:30. Okay.